Welcome to Stormworks, Engineering Meets Combat. In this series, we're diving into the world of shipbuilding, where engineering brilliance meets tactical warfare. Watch as we design, build, and command our cutting-edge fast attack vessel, crafted for speed, power, and precision. From intricate hull designs to advanced weapon systems, get ready to conquer the seas and skies.
Welcome back to episode 4.3. Today, we're connecting all the dots as we finish up our hybrid engine build, refine our engine management, and add a few crucial systems for safety and control. We'll be adding fire suppression, bilge pumps, and, for the first time, reverse functionality to our fluid jets. Let's start right away by piping up the fuel lines properly and getting rid of those temporary small tanks we added earlier. In later episodes, we'll be adding ballast or crossfeed systems to our fuel tanks, but for now, let's just make sure our jets are getting fuel. When it comes to fuel and piping, there isn't much to say, but I do make sure that all lines are serviceable in some way. A damaged fuel line would be devastating if we can't repair it quickly in an emergency. Later on, I'll add hatches and service entrances for easier access. We also need to add air vents to the tanks. Without them, using pumps to supply the jets could build up back pressure, which would starve the engines and lead to failure. Even with a full tank, we'd struggle to pump fuel if it's not properly vented. One thing I've thought about is that our air vents, and eventually our fire suppression system, are positioned very close to the top deck. So I'm considering lowering them, or maybe adding a fake ceiling to the engine room for extra protection. I'm also going to add a bit of color, or lack thereof, to the engine bay. It'll probably change a bit down the line, but adding some contrast makes it easier to see the room and everything else in it. Good enough for now. I'll add walkways, equipment, hoses, and more details later on. But for now, let's get all the functionality in place. We're starting with a fire suppression system. This is very straightforward. Just add piping, some angles, and T-pieces, and connect the loose ends with nozzles. I'm also adding a constant number block, set to 0.7, connected to all the nozzles. This will give the water a nice spread angle when used. Finish it all with a large pump. You could probably go with a smaller one too, but I've got a lot of nozzles, so I think a larger pump will be needed. All that's left is to connect the pumps to a button, add some electricity, and test the system. Looks like it's working, another win. I guess you could say we're on fire, but in a good way. It's looking good, but I'm concerned we're not getting enough spray in the middle. So I'm going to add an additional fire suppression line of nozzles covering the motors too. Here we go, maximum water for maximum satisfaction. Now, we do have a new problem, flooding our engine bay. Let's add the opposite, a way to get the water out, a bilge pump system. This is quite literally the complete opposite of what we've just built. So let's just add a few pumps, but this time have them pump the water out. I'm adding mine to this empty space in the wall. I'll cover them with hatches to make them serviceable. At this point, let me remind you, don't get completely locked by the design you're choosing. There are still more things we need to add to the engine bay, and it's important to be able to adapt as the design evolves. I have a tendency to overthink a lot, and sometimes, I need to remind myself to move forward, not get too stuck on any particular part. I'm using the automatic bilge pump system by R-152004. It's really a complete system, with a status monitor, an alarm, and, as the name implies, it's automatic. Also, the link will be in the description, so be sure to send some love. I like to add two buzzers and select the same sound, but I'll slightly change the pitch on both of them. This creates a cool effect, at least, I like to think so. Let's turn the sprinklers on, and see how the bilge system reacts. As we can see by inspecting the ports on the bilge system, the liquid is flowing out. We can also check the liquid meter, and verify that the levels are slowly diminishing. I am, however, worried that liquid will pool in the lower level at the aft, so I will add additional pumps back there as well. All in all, we've got a working system. Did you know that bilge pumps have been used since ancient times, with early versions dating back to the 3rd century BC? They were crucial for keeping ships afloat during voyages. For now, we'll leave the engine room for a bit. It's looking good, and I'll continue to enhance and improve these systems, providing you with valuable information as I find better ways of doing things. One issue we were having earlier was that we went airborne at higher speeds, so we're tackling that next. We're adding 2 medium control surfaces to the front keel. Hopefully, that will keep us in the water and not living off the edge. Next, a bit of logic. We're adding our trusted blank 1x2, with inputs for tilt sensors, and an output node for the control surface angles. We're incorporating a customizable number property to multiply our tilt sensor's strength. That way, we can control how strongly the control surfaces will react to the amount of tilt we're experiencing. We're simply adding a function block with X and Z inputs, and multiplying our pitch with our multiplier. A numerical switch is placed behind the function block, allowing it to return the correct number if enabled, or 0 if nothing is attached to the switch in the off state. This effectively adds an on and off switch to our stability system. For now, we're adding a constant on block to enable it, then connecting the pitch and roll sensors. These were all placed earlier for the fluid jet stability system, facing left and forward respectively. Lastly, we're connecting the output to the control surfaces. You may have noticed that we also have a roll input on our microcontroller. We'll get back to that later when we're completing the entire stability system. For now, let's focus on one problem at a time. And to continue the trend from earlier, we're also adding a breaker to group all electrical systems related to stability, keeping it neat and tidy. Speaking of neat and tidy, if you like this video, make sure to give it a thumbs up, and if you want to see how the ship evolves, press that subscribe button too. If you disagree, or have a better way to solve some of these systems, let me know in the comments, and together we'll grow a little bit smarter. After all, sharing is caring. Yeah, the control surfaces are placed the wrong way. Looks like we'll need to flip those around to get them working properly. Let's sort that out. So, after that change, I did what any sensible captain would do. I cranked the wind to 100% and sailed far away from any mainland, where we could really put our ship to the test. Let's see how she handles it. I would give that a passing grade for now. After about 15 more minutes, we're way off the coast. This is absolutely the worst kind of condition we could ever encounter. And even though we're running rather deep, we're perfectly stable. We're moving at around 20 knots, more or less straight into the waves, which tells us that our weight and its distribution are quite well placed. Remember, we haven't added anything else other than a few control surfaces at the front and an anti-roll feature to the fluid jets. This could be way worse, so I'm very happy with this. Right, so we know how to go forward, but what about reverse? I'm using the throttle to screen with Dead Zone by Geekness. Link in the description. It's very neat, no need for reverse buttons, just forward and reverse directly on the throttle lever. And using it is easy as pie. Connect the throttle lever, and the throttle output replaces our existing one. Additionally, we're adding 2 buzzers to notify us whether we're moving or idling. That way, we don't visually have to look at the screen to know. Remember to set the sound to whatever you like for the 2 options. After all, who doesn't love a little customization? Let's have a look. We're moving, all good, but what about reverse? Currently, our throttle isn't able to go into the negatives, so let's change that. It's as easy as clicking on the throttle lever and setting the minimum value to -0.25, or something similar. I don't want to be able to go full speed in reverse, hence my reasoning for the relatively high minimum. If you want a bit more speed, you can change this to your liking. Next, we're adding a microcontroller to check if the value is negative. Adding a number input, for throttle, or on or off output for the reverse and a throttle out. We need to provide an abs number block to our variable valves on the fluid jets. An absolute block makes whatever number, positive or negative, represented as positive. So, minus 0.25 becomes just 0.25. If we send the throttle directly to our variable valves without this, they will be shut entirely due to the throttle being in the negatives. Checking if reverse should be enabled is done simply with a threshold gate. It verifies if a number is negative, between minus 0.01 and minus 1. All that's left now is to connect it all, throttle absolute to the variable valves, reverse on or off to our fluid jet controller, and throttle input should come from our newly added throttle controller. Let's test that reverse. Very good, we've got reverse, with steering, and throttling up again sends us in the opposite direction. Perfect. Now, as a finishing touch, I added the logic to our engine management controller for the charging. To me, it was somewhat hard to solve. As a programmer, I can see the solution in terms of while loops and setting a variable or two, but with logic blocks, it wasn't obvious. So, hopefully, this helps a few others. Our objective is simple. At 25%, we want it to charge back to 50%. Both these options are customizable on the controller. So what I ended up with was a greater than block, checking if we're above 50%, and a less than block, checking if we're under 25%. Then, I used a memory register to either set a 1 or 0, setting a 1 if we're below 25%, and resetting it to 0 if we're over 50%. And finally, using a threshold gate, if we're set to 1, we enable the generator. Did I do an okay job? Let me know in the comments. I'll add a coat of paint to the ship after this episode, and publish the ship as well to the workshop so you can check it all. To summarize this episode, we tackled several systems, including fire suppression system and bilge pump system. We also focused on improving stability with control surfaces and a microcontroller for better maneuverability, adding reverse functionality to our throttle control, and setting up a charging system for our generator. Overall, we made significant progress in making our vessel more efficient and seaworthy. Thanks for joining me so far. If you enjoyed this episode, don't forget to give it a thumbs up, and if you want to see more of our ship's evolution, hit that subscribe button. Let me know your thoughts in the comments below. Until next time, keep creating, and again thank you all for the support. Have an amazing rest of your day.